Welcome back. I need to do some more design on my RGBW LED board, so I thought I'd record it here. And I actually have two issues that I need to deal with. The first issue is a size issue. And so I have my dimensioning here tool, and we can see that this is, what's that, 59.4, so about 60 millimeters. By about 22 or 22.25 millimeters. And this is problematic because the application where I want to use it has kind of an internal space where I want to put the drivers. And that internal space is only about 35 millimeters long. Which is much less than 60 millimeter. So this board isn't going to work. And what I've decided to do, it's very convenient to have one board to do all 4 channels. What I'm going to do is I'm going to essentially cut this in half. So I'll build a board that can only do 2 channels, and then I can put 2 of them next to each other inside the space that I have, which is a bit of a pain, and it's going to be a little pricier on a per board basis, but I don't think I have another option. So that's the first issue I need to deal with. The second issue is, sorry, I have to bring up my notes. The second issue is that one of the capacitors I chose, that capacitor I chose that goes here, is now out of stock. So I'm going to have to go back and deal with that. And let's start by doing the out of stock issue. So this is where things get kind of fun when you are doing design. Because when you first start doing design, a lot of times what I do is I look for examples. You know, when you look, other people have examples, and they show you what they're doing, and these are specific components, and you go and buy those components, and that all works. And it's all very simple, or relatively simple. But the problem is when you start wanting to make boards, and especially when you start wanting to make boards or have other people make boards for you and do assembly, it gets a lot more complicated. And basically the problem is you have to take your design, sorry about that. You have to take your design and make it manufacturable. And that may require choosing different parts. That may require making sure that your parts are actually available. It may require changing your design. All sorts of fun stuff. And this is kind of just the tough work when you're trying to manufacture things. So anyway, I have a capacitor that I chose, and I think it's this one right here. And the stock number is now 0, so I can't build with it. So I need to find a different capacitor. So I can go to, there are a couple ways I can do this. GLC PCB has their own online search. So 33 microfarad, 16 volt, case B. Case B is the size, otherwise known as 3528. And that's the size I want. I think that's the size I'm already designed for, though we will see. So I want one of that size, and I can use their search here, and it kind of sort of works. Another option is I can download their library here, and I can search through, and essentially here I did a sort on name. So you can see tantalum capacitor, 33 microfarad, 16 case B, 3528. So I have a whole section here of possibilities. So I can do that. That's one of those are 2 ways of doing this, and then I have a third way of doing it. And the third way, okay, well, so from this I can say, okay, I want to look at this, and I can open up the data sheet. And then I can look at the data sheet and read through and try to glean out what I really care about. And in this case, so this is a Panasonic capacitor. They really don't say what it's for. what I really care about is the series resistance, which shows up here in the specs. And I can actually see these are actually pretty good. These are expressed in milliohms. And if you look at tantalum capacitors in general, you'll see 1 or 2 or 3 or 5 milliohms. And so these are much better than that. So this one, I just happen to know, having looked at this, is this particular part, and it has an ESR of 90, which looks like a pretty good choice. Now, there's another way of going and searching for these. And if you look here, you see there's this thing in their list called LCSC part number. And this is the part number they use to define all the components you're going to place. Well, LCSC is actually a large company, and they do, not surprisingly, parts supply. So what I did is I hopped over to LCSC and started working at products, capacitors, tantalum capacitors, and this gives me a whole bunch of different choices. Okay, so 1646. So I want 33 microfarads. I want 16 volts. And I filter down, and you can see that I now have 30 choices. And I guess I can filter on package if I care. That'd be nice. Sometimes you might find a capacitor that's just a lot bigger than you want. Okay, so I'm down to 20. And in this case, I'm just going to go with Panasonic because I've already chosen one. And then I get down here and I see there are 2 capacitors. But the nice part here is it has availability, it has the part number, but I can scroll over here. And they've actually been nice enough to show me equivalent series resistance in a column. And if I filtered this less, I could have seen a bunch of different ESRs. And that would have told me. Now it turns out this one, the second one, actually doesn't have an ESR listed. They're really the same line, 16TQ, C33, and they're just slightly different variants. Pretty common to see that sort of thing. And I can go and look at the data sheets and figure out this is actually 100. 190, the difference really isn't that drastic. So I've decided to go with this one. Now I can just look at the part number here. Could copy that and go back. I just happen to know it is this one here. Now I don't know if JLC PCB carries all of the parts from LCSC. They may only carry a subset, but it can be useful to go there and search. Now there's another interesting thing here I didn't talk about before, is this little tag here. And this little tag says extended part. And there are 2 kinds of parts in the catalog. There are basic parts and there are extended parts. And the chief difference is how much it costs you to use them. So basic parts are used all over the place, and in the machines that they use to populate the boards in their pick and place machines, they always have the basic parts loaded. So what that means is essentially you don't pay an extra fee, you pay whatever the part costs. Extended part means, yes, we're willing to use this, but we don't keep it loaded. So that means you have to pay someone to go out somehow. You have to pay for some process where those parts are located and they're loaded on a feeder and put into the machine and used to build your boards. And because that costs some time and effort, that costs some money. And for JLC PCB, it costs you an extra $3 per part. This is another part of trying to design for manufacturability, if you can find parts that work, that are basic parts, your boards will be cheaper. Now in my case, for what I'm building, it turns out that all 5 of the parts I'm using are extended parts. So I'm going to pay that $3 every time, which means I'm paying $15 just essentially to get the feeders set up for the parts I want. That also means that my per part cost in small quantities really doesn't matter very much. And these capacitors are kind of expensive, so 43 cents. So that's what we're going to use. So we're going to switch over to use that. So I'm going to take that. And now we can switch back to design. So here's the schematic I've been working with. I'm going to start by giving it another name. I'm going to keep the 4-driver one around. And I'm going to call this LED driver double. Now you may notice there was one called LED driver single, and that was an attempt I tried of putting 1 per board, and it turned out that 1 per board worked, but the boards were about as expensive as the 4-driver board, which meant you get kind of effectively you get 1/4 as many boards for the amount you pay. And part of that is just the overhead and the setup and that sort of thing. So I did that design all the way through and ended up abandoning it. So anyway, we have LED driver double. That's what we're going to call this. And you can see I have 4 examples here. So what I can do, selection is really weird in the schema editor in that it doesn't really show up the way you'd expect it to. So all I did is do that and selected all of those. And now that I've chosen a new capacitor, I'm going to make sure I don't forget that. So go over the capacitor, hit E. This is the LCSC part number of the old capacitor that I was using. So we're going to replace that. And we'll do that on both of them. So now I've got what I want there. The only problem is now my power, so it's called power, it's just the normal jack. It has VN ground, a space, ground, and then it has 4 connectors here. And because I got rid of 2 channels, I don't need 2 anymore. So I could delete this and then re-add the connector back in. But I'm going to do it kind of the quick way. So what I know is from using these footprints, it's a pin header straight. It's 1 row by 8. And I can change that to 1 by 6. And then I can change the library reference to 1 by 6. And now I've essentially told it to use a 6. Now you notice it's a little bit offset. So we bring back and align it. Now I can delete that, and now things are great. So this should be pretty much the design that I'm looking for. So I'll go and save it. Now the next step that you typically do here, I've done this before, is I want to assign footprints. And I already had footprints. Oh, that's really interesting. Okay, I don't know what I just did. Okay, so that was very strange. So assign footprints. Basically, this makes sure that that I have assignments for each of the elements to tell it what the footprint is. And just to pick an example, I'm using 1N5819 diodes, And you can get those in a number of different packages. You can get them in through-hole packages. You can get them in SMD packages. So in this step, this is essentially telling the software exactly the physical shape of what I'm going to be using here. Now these are currently have a package called C means capacitor 1210. And SMD packages, in a very annoying thing, are expressed both in imperial units, US units, and metric units. And so sometimes you see metric units, sometimes you see imperial units. The imperial units are in, what would that be, tenths of an inch or hundredths of an inch. So 1210, that's the size of the package. Other ones might be in expressed in metric. So 1210 and 3528 are about the same, but since the capacitor explicitly says 3528, I'm going to look for a better choice here. And it turns out, already here, capacitors, tantalum, surface mount. And we come over here, and I don't know if you remember, that capacitor was called case B, 3528. And we get over here, and there are actually three choices: hand, reflow, and wave. Hand is intended to give you enough space around it so you could actually hand solder it. I don't know the difference between reflow and wave in terms of the footprints, but I know that my board's going to be wave soldered. So we're going to assign both of those this footprint. And I'm hoping by choosing one that's closer, 1210 would probably work, but since I'm having them build it, this will probably be a little better choice. It might be a little bigger, so I might have to redo my layout. So we will just see. So then I can do OK. So now I have the updated design, and I need to get it over to the schematic designer. And to do that, we generate a netlist. And thought it would be interesting. Happens to be the first one. So this is what the netlist looks like. And basically, it's a description of all the components that are on the schematic and how they're connected together. So we can see, for example, let's find something interesting. Okay, so here we have a component called R1, resistor 1. Its value is 0.2. It has a footprint, resistors, surface mount, 1206 is the size. Doesn't have a data sheet listed, and then it has a field in fields. You can think of these as custom fields. There's a field called LCSC. C25335. So this is the LCSC part number. So that means in this schematic there's enough information. So we have all the components. And then finally down here we have nets, a list of nets, and the nets are actually the connections between the components, which is why it's called a net list. So I'm going to flip over to our design, and I'm also going to call this LED driver double. So it has the same name as the schematic. If you get those different, you're not going to be happy. Okay. Okay. Now, one of the really annoying things that just happened, you notice it said design copied or something like that. In the schematic, I did save as, and I'm now working on LED driver double. In the PCB editor, I did save as, and I'm still working on the old design. So why it works that way, I do not know. So what I need to do is get back and essentially relaunch the PCB editor on that new file that I saved. Really annoying. I don't know why they do that, but that's the way it works. So here's the old design, and this is clearly not in alignment with the current schematic. So I can go to netlist. Since I haven't read it before, it's going to ask me for a netlist file. LED driver double, open. And changes to be applied. It's going to give me a big, long list of changes to be applied. And we have different choices. Match method, I usually like this. What can we do? We can update footprints. Sometimes all you want is update footprints. We can delete extra footprints. In this case, I want to delete extra footprints. So you can see a lot of things that it's doing. It's removing a lot of footprints. Sometimes you'll get errors here, and that may mean you need to go back and look at your schematic and try to figure out what's going on. Now, it says you do update PCB, and it says the changes cannot be undone. Are you sure you want to update the PCB? They aren't automatically saved, so I'm not sure why it does this, because if you don't like what it did, you can just close and relaunch, but it's another weird thing there. Okay, so what happened? So I chose yes, and what happened was all of the components for the third and fourth guy pretty much just disappeared. I still have all the traces. So let's go ahead and save. And now okay, deleted a bunch. I'm just going to do a fair bit of cleanup here. So don't need that, don't need that, don't need that, don't need that, don't need that. Okay, that's probably pretty close. These guys, I guess I don't need. I will need them, but we'll draw new ones. Which I won't need them to the same extent. No. And I don't know if you noticed, we're now back to 4 pins here, 6 pins, rather than the 8 pins we had before. I guess I can delete those too. Now there's also a really big, I don't know if I'm going to let me delete that. So a really big copper pore there. I can delete that because we're not going to need it. Okay. So this, I'm going to pull out to the side. It was intended to be really big because I had lots of board space, and why not? So pull that. It's just on the back. Okay, so that's the first part of what I wanted to do. Now I can start by shrinking the board. And a couple ways of doing this. The simplest, you can do this. I could hit M and move, or I can just move it up. Unfortunately, I've lost those nice labels. So let's try this again. Just a drag select there. Okay. So at that point, that's pretty good. Now the board outline here, I want to move that up. I can drag it up. You notice it has issues going left and right, but that's pretty much par for the course. We'll kind of guess. I'm going to shorten these, assuming I can get them. This I'm going to hold down Control because I want to keep them totally vertical. Hello. Okay, holding down Control. Now I guarantee you that if I ran the, I'll just show you. If I ran the design rules checker, board outline does not form a closed polygon. And basically that's because I did not move things exact. And here if we look at it, we see, well, that's really obvious. So simplest thing to do, zoom way in. And once again, hold down Control. Get that so that's aligned, and then this one's a little off. And just adjust. You get the circles when they're totally in alignment. Now let's go over to the other side. Take this guy, holding down Control. Go to the other guy, holding down Control. And now those two are perfect. So go back, design rule checker. So I got rid of the errors there. I now have problems with courtyards overlapping. And first, I am going to have some copper fills here. And thanks to whoever suggested doing that. Okay, so you see we have some problems here. Look at all those arrows. Okay, remember when I was talking about the capacitors and their sizes? So having this capacitor here have the actual size pad it should have, rather than the 1210, which it had before, has led to a number of issues here. So, courtyards are these little white things around the outside. And the courtyards are designed to be sections that don't overlap, which is why it's telling me the courtyards are overlapping. And basically, courtyards overlapping means we don't have enough space. And this is going to be kind of interesting to see what we can do here. So with the previous design, you know, I jammed things as close together as I could, kind of because I wanted things really tight. So let's see what we can do. We have quite a bit of overlap here. Okay, so that's clearly problematic. We got quite a bit longer. We have overlap here and overlap here. We might, I'm going to select M for move. Enter to accept it. Okay, so that kind of got rid of that one. I'm not sure I can move this guy up enough. M for move. So basically, oh, there I did the usual thing. So in terms of what overlapping means, it's not touching. So that should be okay. If I go, and that should actually be okay, they should be in the same line. If I go to there, now they're overlapping. So if you think of the lines having zero width, that's what we're concerned about. So that would be probably as tight as I could go. Let's just run our tools again. Okay, and you notice I got rid of the courtyards overlap there. Where do I still have courtyards overlapping? It's not surprising. You can see this is one edge of the PT4115 here. See if I get that selected, and now let me select the capacitor. Well, pretty clearly those are overlapping. So move the PT out. Once again, I did what I didn't want to do. Sorry about that. Okay, so I've moved that out to the side. I think there might be an overlap here. Inspect again. Okay, so this is a different problem. That's complaining about this trace being off because I moved those things. And we're going to move this too because it's nice if it's kind of centered. And once again, problems. Okay. Delete a trace, delete a trace. Run the checker again. And I think I've gotten rid of all the issues on the upper one. And the question is, what do I think of that, having to change that? And it's like, well, that really was not as bad as I feared. I was really worried that I wouldn't have enough vertical. I don't mind going a little wider, but I thought that I was going to have to push the board a little more vertical. And basically what I did is kind of took a little space above where the inductor was. Now, just to make this a little nicer, I'm going to kind of center the inductor, give us a little space between the inductors. I think that'll just be nicer. So that is kind of what we were wanting. Now, of course, problematically, because I've moved things around, the whole layout is not the way I want it now. Okay, so thinking. So we have a little problem here in that here I could push up a little bit, but we have this crosstrack here. And what you can see is this crosstrack is actually taking a little space that the LED would take. And I think we're going to try to do the same thing and move and just push the LED. I'm going to push it right too. I didn't do that on the other one. Now here the LED is above the inductor. Here it's just kind of up even with the inductor. So it means we're going to have to shift all of these down just a little bit. But I think that's going to be fine. I think we actually have space. I don't need those. So zoom in. Let's start by moving this guy to the right. and this guy down. Now, there are different ways of doing this. People will do it where they select the tracks, and you can also use G and drag, and that kind of moves everything around. I typically would prefer to move just the components and then rip up the tracks and redo it. This is really kind of a personal preference thing. So make your own choice. This time I'm going to select all three of these, and let's see if we can move them all to a layout that works. That looks better. Design rules, checker, run DRC, track too close to pad. Okay, that's the only thing. The only problem we have is some of the vias here are now overlapped, and that is perfectly okay. So I'm gonna move this out to the edge so it's kind of like the other one. And okay. So now let's tear up some tracks so we can redo them the way we want. And if there's anything I've gotten good at, it's redoing tracks. Simply because, well, I kind of like the routing part. And if I redo them, I know that everything is set up the way I want it to be. I know all the tracks are automatically centered. Now this one I can tell. We zoom in a little. You can see that's this end is lower. There I can do a G and pull it up. I'll do that sometimes. Okay, what am I missing? I'm missing ground here and ground there. There's a This is kind of annoying because it's going to try to grab onto the via. It's just trying to be helpful. So let's select those vias, move them. And I'm looking at this, looking at the line coming from the pad on the left. So that way I made it straight, and that way I know that's fine. I'll do the same thing out here. And that's fine. Okay, back to routing. Okay, we see that's fine. And then I just need that little. Okay, so that's the top all routed. Again, except for ground. And that's because we have a ground on the back. So I'll switch over, ground. And I'm not sure that's quite perfect vertically, and it doesn't matter at all. So let's go save again. So how are we looking? We're looking pretty good on the top. The only thing that's problematic that I see is the location of these vias. So let's drag them to where I want them. So basically what I'm doing with the vias, these vias, I'm trying to make sure that I have, there's one more thing I need to do. Okay, so I want to make sure I have plenty of capacity to pull current from the back plane onto this front plane for the ground. So that happens here, and then that happens here. These vias are all going to hit the copper pore on the back, as will these vias. Right now it doesn't look like they're doing a lot, but they actually are. So I think that's all done for the top one, except for this guy right here. And that's the dimmer guy there. So we're going to lose that. And I'm going to move the via. Unfortunately, I lost the rat's nest. It's a little weird. Okay, that's pretty darn close to vertical. So, I'm going to need a thin track. Routing from the back to there. And there I'm switching to the front. Coming across. And there we are. So that's layout of all of the top one. So let's go to the bottom. First, like I did before, tear up the tracks. It is just easier. There's probably a smarter way to do this than what I'm doing. I'm pretty sure there's a way to do selection and say, a drag selection and say, just give me the tracks. But in this case, it doesn't matter terribly much. Okay, so move to the vias. Let's start doing some routing. Back up to 1 millimeter. Okay, so I'm going to need a V in there. LED comes across. LED, V in, V in, V in, and V in. So, how are we doing? Okay, these guys are not in the right place. Okay, let's do that. That. Close my tool and let's move these. That's about in the right spot. Nope, too close. Okay, we're going to route that anyway. Okay, that's what I'm trying to use G. Yeah, that's not the right tool here. Okay, select those. Move them, and let's just move them a little left to about there. That's probably good enough. Once again, tear up, route, route. And you notice I still show this rat's nest line. That's because I am missing that. Okay, that looks a whole lot cleaner and a whole lot nicer. What am I missing? I'm missing a connection from this ground across. So I'm just going to do that like that. That will be sufficient. I'm not too worried. I used a big trace here. This is only kind of a data ground, so it doesn't really matter. These are the ones that see hefty currents, so they're the ones I'm most concerned about. So how are we doing? I think we are doing okay. Design rules again, and track too close to pad. So This is complaining because this pad does not have a connection on it. And there are two ways that I could fix this. I can either change that track I just added to come up here and tie in, or I can change this pad in the schematic so that it actually has connection to ground, and then that would make it happy. Or I can just ignore it, which I'm going to do for now. I'll probably fix it. Tiny little leftover there. Okay. That is not what I wanted. It also gave me one up here. And as you can see, when I talked about overlap, you can see that this LED is just a little bit too low. But, okay, I did a move, and move when you're zoomed in too much is problematic. It gets confused. Okay, so all we're left is that one down here. And I'll probably go back and fix that later. You also notice a little weirdness here. You notice there are some rat's nest lines here. I don't know why. List unconnected. Okay, so it thinks that there are some unconnected pads. I'm not sure where it's showing me. I don't see any. I have to remember that the tools are not perfect. Okay, so that is looking pretty nice. Pretty nice. Now there was something somebody did and actually sent me a change set on the last one, which I found kind of interesting and kind of, I guess interesting is a good word. So they did a pour, a copper pour with VN to come across and cover all of these. I thought that was an interesting thing to do. So we're going to do that. So I want something that will encompass kind of from here. And I'll show you where it is. Okay, so it's going to be on the front. It is the net name VN. And I want it to be solid. And choosing that's actually pretty important. Okay, holding down Control again to keep it square. I want to come across, okay, click there. I want to come across and get that VN all the way across over here and then double click. And what you noticed is not only did I get the copper pour, but it very nicely kept clearance here and clearance here and clearance here. So that just gives me kind of a nicer view, and it's also nicer in that I don't know which of these pins is using the most power. So having them all tied together just makes things nice. So we'll do the same thing here. It's going to ask me the same thing. Okay, hold down Control, cross, double click. And there now we've got a nice copper pour there. And similarly, I want a big ass copper pour for the back, for the ground plane. So flip to ground plane. And I'm pretty much just gonna do the whole thing. So on the back, ground, solid. There, I still haven't made it bigger, but there, and I guess I can just double click there. Okay. And now we see the full back plane. Nicely done. Now, the only thing I don't like about this is these guys. This just looks a little weird. The ground plane kind of comes in around these, and I find that a little annoying. So we're going to use an exclusion zone, which basically is going to say, don't put ground plane in a specific place. So it's a keep out area. It's on the back. Tracks and vias are okay. I want to keep out copper pores. So okay, that's there. This hasn't recalculated yet, so don't worry about it. And I'll do another one here. So at this point, there's probably a nice way just to cause this to recalculate. One way I know that works is if I can find a place to select. I have the whole copper pore, hit E, hit OK, and then it did a recalculate on the way out. And you notice now I have space there. Now obviously this occludes most of what I want to see, so I can turn them to hatched. There's also this weird outline mode, which I guess some people like, but I generally just turn them all, keep them turned off. So that is about 50 minutes, which I think is probably more time than most people care about. So I'm going to stop at this point, and I need to fix this issue down here, and I need to make the board a little wider, but I don't think either of those are very interesting. I'll probably do a third video that talks about how the submission actually works and what files you need to do the submission. So thanks for your watching. Have a good day.